ionic compounds is what we want to focus on here. Okay, so whenever we're in this section from here until the end of the lesson, we're talking about ionic compounds. And we'll look at this example down here to show us, remind us, we have a cation and an anion. Alright, so ionic compounds that contain the ammonium cation, for example, could create an acidic solution. Ammonium, which you see as our cation here, is the conjugate acid of NH3. And NH3 is a weak base. So ammonium, the conjugate acid, could act as a decent acid. So you see here, if you have ammonium nitrate that is added to water, the ammonium ion could react with the water to form ammonia and H3O+. Because we just formed H3O+, the pH would drop below 7. So if you looked at this, salt is what we call all ionic compounds. It doesn't look to be acidic or basic. It's got ammonium in it and nitrate. We don't think of either of those as acids or bases. But ammonium is a conjugate acid of a weak base, and so it could act like an acid in water. Notice, double arrow, it's a weak acid. It's not going to drop it much below 7. It's not going to do much to the pH, but it does affect it. Now, nitrate is our anion. Why does it not act as an acid or base? Nitrate is the conjugate of nitric acid, and nitric acid is a strong acid, therefore its conjugate is a crappy base. Also remember, NO3 molecules are always soluble spectators, so it's not going to act like an acid or a base in water. Alright? Some other examples of things that could act like acids are monoatomic cations. Okay, and we'll talk about why as we look here. The cations can attract the negative poles, right, the oxygen part of the water. And the positively charged cation will then decrease this bond strength in the water. So therefore some hydrogen ions could break free from the water. For example, if iron 3 chloride was added to water, the iron 3 could pick up some water. And what it's doing is the oxygen part of the water is surrounding the iron, right? We've drawn these pictures before. What could happen as that occurs is the hydrogen bond in water between the oxygen and the hydrogen could be broken on 1, 2 of them maybe, and leave us with, instead of 6 waters around it, 5 waters and 1 hydroxide. So then we just released a hydrogen into the water, and that hydrogen that we released would cause the pH to drop. All right, so we looked at conjugates can change the pH, and now we're looking at monoatomic cations like iron, other metals that would be positively charged. They could change the pH of the solution. Which ions could do this? Okay, could sodium ion do that? No. Okay, so which ions could cause this to happen for water? As the radius decreases, so as these ions get smaller, they're going to be better at causing the solution to be acidic. And also as they have bigger charges, right? This is Coulomb's law. So if the size is small and the charge is large, then they're going to be better at pulling water to themselves and potentially releasing a hydrogen from the water. For example, iron plus 3 would be better at this than iron plus 2 because its charge is larger. And because it lost another electron, its size is actually smaller. So iron plus 3 would be better at that than iron plus 2. If you have ions that are conjugates of a strong base, for example, anything from group 1 or calcium, strontium, or barium, these will not affect the pH. But any other metal ion will. The only difference is going to be how much it affects the pH. So if the metal is small with a big charge, then it's going to have a greater effect on a metal that's big with a small charge. All right. What about things that make the solution basic? If you have an anion that's a conjugate of a weak acid, it could accept a proton to produce hydroxide. For example, let's look down here, sodium CH3CO2, I'm not sure, that's acetate, right? Yeah, sodium acetate. So acetate is the conjugate of acetic acid. Acetic acid is a weak acid, which means acetate could also act as a pretty good base. So acetate, just the ion, could react with water to pick up a hydrogen, and when it picks up the hydrogen off of water, it will leave us with hydroxide ions. If we're making hydroxide, that's going to make the pH go up. So some anions, negatively charged things, could make the solution basic if they are the conjugates of a weak acid. If they are the conjugates of a strong acid, like chloride comes from HCl, perchlorate comes from perchloric acid. These all come from strong acids. They do not accept protons because the conjugate of a strong acid is a terrible base, so they do not affect the pH. So we're looking for conjugates of weak acids that will affect our pH. So here we have sodium in the salt as well, right? But sodium comes from sodium hydroxide. That's its base, and that's a strong base. So sodium, being the spectator in that strong base, will have no effect on the pH of water. But that acetate ion, it can pick up a hydrogen and cause our pH to drop. All right, some other examples here. If we have HSO4, we know that is the conjugate of H2SO4. And H2SO4 is a strong acid. So HSO4 negative 2 is not going to act as a base. However, it can act as an acid. It could give away another hydrogen. And there's the Ka value. We call that Ka2, since it's giving away that second hydrogen. So its conjugate is a very weak base, right? So H2SO4 is a strong acid. Its conjugate is also an acid or a base, but it's a better acid than it is a base. So it will lose another hydrogen to form SO4 negative 2. So that's its conjugate base, and it is a very weak base. If we have this salt, sodium sulfate, we know the sodium is a spectator, right? But the sulfate comes from a weak acid, HSO4, not H2SO4, because we only gain and lose one hydrogen at a time, but HSO4 is its conjugate, which is a weak acid, so this could pick up a hydrogen to cause small changes in the pH. All right, a few other things that change the pH here, metal oxides. If you have a metal attached to oxygen, not hydroxide, we know that's a base, but if you have a metal attached to oxygen, then it can do this right here. It can break apart into your metal and your oxygen. Then your oxygen can go pick up a hydrogen from water and make some hydroxide in the solution. All right? Now, these are not completely soluble, but they are partially soluble, and so it only increases the pH slightly. So this is not a complete reaction. Once we form this hydroxide, which is like the fourth step down here, these are only slightly soluble. So the takeaway so far, you need to go back and list all the things that can change the pH of the solution. I want you to make a list, like on a separate sheet of paper, and then tell me if they're going to make the solution more acidic or more basic. All right, so metal oxides, if you see a metal attached to oxygen, it is going to make the solution more basic because you're going to end up with the metal hydroxide, which can then dissociate and give us hydroxide in water. potassium oxide, for example, potassium oxide is going to form your oxide and your potassium. Then the oxide will pick up hydrogens to form hydroxide. And then we know that potassium hydroxide is completely soluble. So you see there, unlike magnesium hydroxide, it's going to break completely apart. So it would change the pH more than magnesium hydroxide because magnesium hydroxide is not completely soluble. Alright, sometimes we'll have salts and they have weak acids and weak bases inside them. And other salts will actually have strong acid conjugates and strong base conjugates inside them. Either way, these have no effect on the pH. So for example, in this salt, this ammonium acetate, we have ammonium, which could donate a hydrogen because it's the conjugate of a weak base, and acetate, which could accept the hydrogen because it's the conjugate of a weak acid. So we have two weak conjugates here. They are doing opposite things. One's donating, one's accepting. So overall, there's going to be no or very little minimal effect on the pH. Another example here, you have copper fluoride. So if that dissolves in water, you get copper ions. We know metal ions create acidic solutions because they pick up those waters and then the water can lose a hydrogen. And then you have fluoride ions, which is the conjugate of a weak acid. So it could accept a hydrogen and act like a base. These two, again, are doing competing things, so little to no effect on the pH. So again, this is very conceptual. You're going to see a lot of multiple choice questions where it's asking you, okay, here's the compound. Is the pH going to be higher than 7, lower than 7, or no effect? So you need to know what types of compounds cause the pH to do what. And we're going to build on this as we move into the next section. So again, if you didn't already, go back and make a list of all the different things that could change the pH of the solution and whether that change is going to be large or small, whether it's going to make the pH go up or down.